Hello, in this video, we present the fifth synthesis of cannabidiol, which is in accordance with the retrosynthesis number 4 that was presented in the previous video. In this synthesis, the chiral allylic alcohol and the methylhexanoic acid are both prepared in a parallel fashion and starting from commercially available raw materials. These precursors, upon esterification, generate the dienoester, which, through an Ireland-Claisen rearrangement, will then yield, via subsequent transformations, the dienomethyl ketone. That will ultimately lead to the generation of the cyclohexene ring of the final product through the application of a Grubbs olefin metathesis reaction. As we will see later, preparation of asymmetric allylic alcohol. Initially, the phenol groups present in olivetol are protected by converting them into methyl ethers using dimethyl sulfate in order to yield the protected compound 3. Its treatment with sec-butyllithium methylates the ortho position to both esters, and upon reacting with dimethyl formamide, benzaldehyde 5 is obtained. When benzaldehyde 5 reacts with acetone through an aldol condensation, conjugated ketone 7 is formed. Asymmetric reduction of ketone 7 with borane in the presence of RCBS, which acts as a chiral auxiliary, generates the asymmetric allylic alcohol 8. Preparation of methylhexanoic acid, isobutylene 9, and formaldehyde 10 are reacted through the Prinz reaction. This generates the homoallylic alcohol 11. The primary alcohol 11, upon reacting with mesyl chloride, forms mesylate 12, which is then used without further purification in the subsequent reaction. Diethyl malonate 13, in the presence of sodium hydride, forms its conjugate base, which then reacts with the mesylate through a nucleophilic substitution to generate the substituted malonate 14. The ester groups are subjected to hydrolysis with lithium hydroxide to produce diacid 15. Subsequently, 15 is then heated in the presence of pyridine to induce decarboxylation, leading to the formation of monoacid 16. Final steps in the synthesis of cannabidiol. The esterification reaction, occurring between allylic alcohol 8 and carboxylic acid 16, when carried out in the presence of DCC, results in the formation of ester 17. The treatment with KHMDS forms the conjugate base of compound 17. The treatment with chlorotrimethylsilane, it subsequently yields silylated anyl 18. Compound 18, in its conformation, 19 is useful to visualize the Ireland-Claisen rearrangement, which then forms the carboxylic acid 20. The subsequent addition of methyl lithium leads to the formation of methyl ketone 22. The intramolecular olefin metathesis reaction of diene 22 in the presence of the second generation of Grubbs catalyst. It begins by forming intermediate 23 via 2+2 addition to the indicated double bond, and its extrusion generates intermediate 24. A 2+2 intramolecular addition to the other double bond forms metallocyclobutane 25, which, through an extrusion process, generates the desired cyclohexene in compound 26. The reaction of ketone 26 with methylphosphonium salt gives a methylene in compound 28. Finally, the deprotection of the phenol groups is carried out first with the methyl Grignard reagent, followed by vacuum heating to produce the final product with 62% yield. In summary, here are the raw materials and their structural contribution. Thank you for your attention.